to get spin 1, 3, we just need our 4 fingers. So we can cross them like this to get that double helix, or a quad helix really. This is the crisscross doubles. Now, this is just gravitational waves, so we can go, right? But what if we wanted to take a look at the internal fibers? So in order to do that, we have to hold one of the strands completely still. I'll keep that middle finger still, and I'll let the other strands oscillate around it. So I can go like this, keeping that middle finger still, and we can see what's happening as we hold one of these strands fixed. So we're just seeing the internal fibers. Let's take away that finger, and here's what the internal fiber space looks like. It's still connected to the to the quad helix over here, but you can see it's now sort of this triple helix type of shape, sort of more like this SU3, but it's not a real triple helix. It's not just straight up a triple helix. It's this double helix with an orthogonal single strand. So that gives us this structure. We can break it apart as SU3 because we can sort of twiddle our fingers like this and we can make the SU3 happen. Or we can only focus on the flipping the SU2 part. So we just can flip these fingers if we want, and we can get to SU2. Or we can only flip one strand, like this. So we can get all the different rotations and interactions by crisscrossing our fingers. One like this, or we can go back to our original spin 2. Now this looks like it might be in 10 dimensions, but really we have 4 space-time dimensions, which is this sort of structure, which builds a tower of fields. Not just one, but all the fields. It builds spin 2 fields, it builds 2 spin 1 fields, and then it builds a spin 0 field. And all those fields together are this spin 1, 3 thing. So you get all the fields right there. And as you can see, you just hold one of the strands still, and now you're in internal fiber space, so you can see the DNA of space-time. But the internal fiber space requires this Calabi-Yau threefold. So it's a 3-dimensional complex space, since we're sort of rotating things around. And if you look at complex space, each complex dimension has sort of 2 dimensions. And if we look at this, the reason we have to use this Calabi-Yau threefold is because the number of generations that are allowed on the Calabi-Yau threefold is 3. And that's because of this formula here. We have to take 6 dimensions divided by 2, and then you'll get 3 families. So this is the 3 generations of particles that happen from our Calabi-Yau threefold.